Hello and welcome back to another video. Today we're going to be discussing more tips and tricks in the Linux command line or the terminal interface. And this is part 3 of my how to use the Linux terminal series. And today specifically we're going to be touching on network interfaces and systemd. And what systemd is, it's the backend application that manages running services on Linux machines. And then from there, we'll also talk about SSH and spinning up a default Apache web server and how the associated systemd commands that we need to run. So first off, I may have touched on this in my previous videos, but we have a command here, ifconfig, and on if you're familiar with Windows, it's very similar to ipconfig on Windows. It shows you your network interface configurations, their IP addresses, their subnet masks, um, all that good stuff here. So in my setup here, we have three network interfaces. We have the EMP0S3, and this one is getting its IP address from the VirtualBox network, the NAT adapter. So this one is running what's known as DHCP, which is Dynamic Host Configuration Protocol. And what that does, it goes out. So when you connect to your computer, most computers do this automatically. If you're on a Windows machine and you connect to your network at home, your router is gonna give you an IP address to talk to other computers on the network. It calls out. It says, hey, I need an IP, it gets it. So that's what's going on with this one here. The EMP0S8 adapter is static down. So this one is hard code. It's hard configured in a configuration file. So every time you boot the computer, the interface is going to have this IP address, at least in my case. And then, of course, LO is just the loopback adapter, which loops everything back to your host machine. So that's our network interfaces. Now, how to configure those static IP addresses on Ubuntu. First, you can use ifconfig and do it manually, but in my case, when I do it this way, it tends to like to revert back to DHCP, especially if you're doing it on an interface that has DHCP enabled. After a while, it will generally try to revert back to its default. But sometimes I will do this just to test connections real quick instead of going into configuration files. So to set a static IP address, let's say on the EMP0S8 manually, we would do ifconfig and then specify the interface, and then we can put in a specified address here. So we'll do 155, and then of course we do the /24, which is saying that our subnet mask has 24 bits enabled. And I may have mentioned this, so each of these octets here, sections of the IP, is equivalent to 8 bits, and 8 bits enabled adds up to 255, and this number, you can think of it as 8 times 3. So we have 8 bits here, 8 bits here, 8 bits here, that's 24, and then 0 bits here enabled, that's why that's a 0. So we run that. Let's see, I put the interface in wrong. There we go. So now if we do ifconfig again, we see now our IP address has changed to 155. So that's how you can do it manually through the command line. And you do need sudo privileges, as you have seen. That requires administrative privileges to change IP addresses. Now, if you wanted to make this persistent and do it through the configuration, depending on the Linux distribution you're on, this might be a different process. On older versions or older versions of Ubuntu, normally you would do it through the network folder here, and there would be an interface file where you can configure your interfaces. However, on newer versions, they opted to this process to be done through the Netplan directory here. And if we go to 50 cloud init YAML, we can see our interface configurations here. So this is the syntax. So you would follow the syntax similar to how I have it here. So it's essentially it's like a tree. We have the network, the version. We had set that to 2, and then our Ethernet interfaces. So we have the EMP0S3, which has DHCP set to true. So this is going to get its IP address automatically from the network. And then we have the other interface, which we just played around with, and we manually set the static IP on that. And this one has an IP address of 192.168.56.165 on boot. So, or when this is applied, with the DHCP set to false. So it's not going to go out and try to get a IP address for this interface. And then we set up our routes. Our routes would be to our default gateway. So we have routes to default via 192.168.1.1 or whatever you want to put in here. So for most people, it would probably be 1.1. And then we have our name servers, which this tells this is our DNS servers. And in here I have 8.8.8.8, which is Google DNS, and then Cloudflare DNS, which is 1.1.1.1. So that is how you would set that up. Now, another interesting thing you might be wondering here. So DHCP, we don't have to worry about, I just want to touch on this, yeah. So we don't have to worry about setting routes or doing name servers. We can specify name server up here if we choose to, but when the DHCP server gives you your IP address, it also gives you your route information. It knows where the gateway is, and it also gives you whatever its DNS configurations are. So essentially, it gives you everything you need to connect to the internet and communicate to other computers on the network. So that's why under here we have a bit more information other than just the addresses. We also have our routes and our name servers, and up here we just have a simple DHCP4 true. And DHCP4 meaning IPv4. There is IPv6 as well, which I'll touch on in another video. But for now, we'll keep it as DHCP4 for simplicity. So once you have our configuration file here, to apply these configurations, and currently we can see that I still have a 155. We do a Netplan. We can test it first. Netplan, is it try? Excuse me. So we could try it, and we can ensure that our network is, our communications are still good, and if there is an issue, it will revert in was it 3 minutes or 2 minutes? 2 minutes. Or if we are happy with our configuration, as we can see, it was updated, we can hit enter, and it'll accept the configurations. Now, if you want to skip the try, you can also just do sudo netplan apply. This will just go ahead and apply it automatically right away with no testing or trying. On servers and enterprise stuff, if you're doing this and you're changing IP address schemas and you need continuous connectivity, trying might be better. But for testing and playing around on your home machine, if you want to just go ahead and send it through and you're confident, go ahead. So that is how you set your static IP addresses and do your check your network configurations. Now let's talk about systemd and the Ubuntu services. So systemd starts up on boot, and we can see our services in here. If we do systemctl, we can see all of our services that are running on or all the available ones, and which ones are active and which ones are not active, right? So we can see all those. And if there's one in here that returns an error or something on the lines of that, we can also see it in this list too. But if we know, say if we want to run a service or start it up, we would do systemctl, and in this case I'll start up Apache 2. And what Apache 2 is a web server that runs on Linux. You can also run it on Windows. And if we go to our loopback adapter, we have a little web page here. So to start it, you would use the start directive, and if you need to get some more information about system control, we can also, use the man page and view our available options here and what we can do. So we have the start, which starts, we have a stop, reload, restart, right? And then of course, if we want to stop it, we can do Apache 2, stop Apache 2, refresh the page, and now it's gone. That's how you would start services and stop them. And then say in the event there is a misconfiguration and there's an error, and when you do systemctl start, that's a common thing. So I'll give you an example. Let's say if we install a conflicting web server. Let's say if we have Nginx, which is another server that runs on the same port, and you can't have two services running on the same port. So what happens is you're going to return, it's going to return an error when you try to start it up. So let's say we try to start, and we see that we have an error here. So a way that you can see the error logs using systemctl, we have systemctl status nginx. So we could do system status nginx, and it will give us some information about why our service failed to start. So in this case, we can see that nginx tried to bind, which means it tried to listen or bind itself to port 80 on all interfaces, and it failed because the address is already in use. So how do you fix that? Well, we can just say, or else if I want to use nginx instead of Apache, we stop Apache and we start nginx. Then we can look at that status again, and now it's running properly. So that's how you would troubleshoot services on Ubuntu Linux. You can use the systemctl, and it'll show your service information. And now another thing, we'll touch back on the networking side real quick here. Now let's say if you wanted to see what services are running on what ports. Well, there's a couple ways you can do it. My preferred way is using the netstat, um, tool here. Now this netstat's not installed by default anymore. It used to be on Ubuntu, but they removed it. But you can still download it by doing sudo apt install nettools, and this will go out and get you your netstat. So let's say if we wanted to see what ports are open on our system here, we could do a netstat minus an, which means all, and n means numeric. It means that it's going to put our IP addressing information in numeric mode. Now, if we leave that out and you're connecting to like DNS resolved addresses like google.com or something like that, where that has like a friendly name like Google or whatever, it's going to show that instead. If we leave the n in there, it's actually going to give you the specific IP address that it's connecting to. And we don't have to worry about the bottom part here. That's usually why I like to pipe it through head, because it's the top of this output we really want to focus on here. 250, so we can split it up and we can explain this. So the top portion here tells us our active internet connections. Down here is our Unix domain sockets. This is more for applications and socket files that are on your local machine. But if you're interested about like services where people can connect to you through and what you have listening to the general, the broader network, you're going to want to look at your internet connections here. And in this, in the drop down here, we have the protocol. We could see TCP and UDP protocols. We have some received information, sent information, our local address. This is the address that everything is listening on our machine. And of course, a foreign address of where either we're connecting to or what's connecting to us. And then our state, which means tells us if there's an established connection or if we're just listening, right? So that is how we can see that. And right here, we see our port 80, which is running our, well, now it's running our Nginx server instead of our Apache server, even though it still pulls up our Apache default page. So now if we were to rerun that, we can see now we have an established connection from our local machine to our local port 80. So this is the actual connection that I just created with the web browser here. So we can see that, and this is useful for, you know, keeping track of what IP addresses are connecting to what. You can come in here and look to see if there's like any suspicious IPs connecting to like administrative ports. Like you might have like a public IP address connecting to your SSH port, and you're like, where the heck is that coming from, right? And then if it doesn't look right, you can block it. So that's where this tool is extremely useful. So that is how you can monitor for that. Now let's say if we wanted a SSH server running, we can do sudo systemctl start SSH. And now if we pull up our netstat again here, now we see we have a TCP connection or listening on port 22. And if I were to, let's see, can I split this? No. Well, I have tmux. I want to just split the terminal. No, okay. Don't worry about it. Let's say if I were to connect back in to the local host here and loop back in. So if we look at our connections again, we'll see that we have an established connection on port 22 from the loopback, from our loopback adapter, connecting into SSH. So that is how you would start and close services, start stop services on Linux here. Now, let's say if you want to have these services start up on system boot. There is another directive with system control. It is the enable directive. So say if I wanted to enable SSH, meaning that when I reboot the machine, it's going to automatically start. That's this. Now we have a symlink. So what this did is it created a symlink in the systemd directory, meaning that when systemd initiates, and systemd initiates every time you boot the computer. It's what makes the operating system or the Linux operating system spin up in this case. It's gonna automatically start the SSH service. Now, let's say if you want to disable it, it's as easy as systemctl disable SSH, and that's gonna remove the SSH service. So now it's deactivated. It's not gonna, you would have to start it manually like this every time you boot the computer. So that is some of the basics on networking, network interfacing, and the systemd and managing network services on Ubuntu. And these commands, say if you were doing this on a server, on an Ubuntu server of you know, the latest version, these commands would work just exactly how I've explained them here. So, you know, I hope this was informative, and everybody have a great day.